Hello teacher, this video is made by Lintou. For the question 1, the first step is to import the data to the Excel, which is shown here. I use two methods to analyze PSI. Method 1 is to use average of PSI to analyze. I calculate average of PSI per month per region, which is shown in this table. From the table and the chart, we can see clearly, in June, Central region becomes the best place who have good air quality. From July to September, Eastern region has the best air quality, but the West region has the worst air quality. Method 2. Use median or mode of PSI to analyze. You can see this table, which is median of PSI. From the table, Eastern region has the best air quality from June to September. The Western region has the worst air quality from July to September. The mode of PSI, the mode value is the data set occurs most frequently, is not affected by the outliers. So from the table, Eastern can become the best region that has the best air quality for the 3 times. For the 3 times, which is June, July, and September. However, Western region has the worst air quality in June, August, and September. So, I think the East region of Singapore has the best air quality. West region of Singapore has the worst air quality between June 1st and October 31st. As we can see here is the worst air quality region, which is the West region. How can I get these 5 charts? I analyze the data from here and I count the daily maximum PXR, which is shown here, the West region. Then I use this data change into the line chart. The advantage of the line chart is that we can see the daily changes very clearly. The line can go up, can also goes down. So from the chart we can see the West region had serious air pollution in June, which reached around 227. However, in July and October, the highest level of daily max of PXI is around 50. In August and September, the highest level of daily max of PXI is around 45. For the question 2, construct 95 confidential interval of the mean PSI reading for the 5 months. So by the central limit theorem, the probability distribution of a random variance variable will tend towards the normal distribution when n is more than 30. From our data, we know that our size, the n is more than 30, so we can use this formula to help us. The first step is to find the average of PXI in 5 months. So I use this data to calculate the X bar. 95 confidential interval means alpha equals to 0.05. So before we get the standard deviation, we need to find the variance first, which is this value. Then I get standard deviation. Also, because I know the alpha, I found the Z value, which is 0.96. Then next, I get the sampling error. For the lower limit, it's X bar minus sampling error. Upper limit is X bar plus sampling error. So here I got the result. Thus, 95 confidential interval of the mean PSI is from 31.05 to 31.80, because I keep in 2 decimal number. For the second one, PXR is more than 30 for months of July and August compared to in September and October. So in order to determine there is significant difference in the proportion of bad air days in these two periods, we need to get this table first. How can I get this table? I count the daily max PSR first in 5 regions, which is shown here. Then I count total days PSR is more than 30 and I record in this table. From this table, we can note that June and August total days PSR is more than 30 is 143, and September and October one is 127. 1% level of significance means alpha equals to 0.01. July and August for all regions P1 means 143 divided by 310. How can I get this value? As we know, July and August the total days is 62, but we have 5 regions, so the value is 310. Similarly, we can get P2, which is shown here, and size N2 305. How can I get this one? Because September and October the total days is 61, but we have 5 regions, so we can get 305. I set null hypothesis as P1 equals to P2, therefore alternative is P1 is not equals to P2. From the alpha, I can get the critical value, which is shown here 2.575. In order to get test statistic, we can use this function, and then we get these values. Since the test statistics value, this one, is less than 2.575, which is critical value, so it does not lie in the rejection region. There is not enough sufficient evidence to reject the null hypothesis 1% level of significance, so we can see that there is no significant difference in proportion of bad areas in the two periods. Thank you very much.